Question 3. Find the values of x, which is the domain, which satisfy the quadratic 2x squared plus 2x minus 5 greater than 3x minus 2. In order to do this, I can do algebraically and graphically. So I'm going to do both. Algebraically, 2x squared plus 2x minus 5 greater than 3x minus 2. I'm going to subtract 3x from both sides and add 2 to both sides. So I'm going to get 2x squared minus x minus 3 greater than 0. So what I did was I added plus 2 to both sides and also take away minus 3x from both sides. And then what I need to do here is to either factorize. 3 and 2 will do it for me. But I want to use completing the square. So let's do that. I'm going to take 2 out from the first two terms. So that will be x squared minus x over 2 close bracket minus 3 is greater than 0. So what I did was, if I multiply them, open the bracket again, I'll get the top back. That means 2 times x squared is 2x squared. 2 times minus x over 2 is minus x. So all I did was making the coefficient of x squared 1. Now I'm going to apply completing the square to the first two terms in the square bracket. When I'm doing completing the square, this is what I'm doing. If I'm doing completing the square on something like x squared plus bx, then my completing the square would be x plus b over 2 squared minus b over 2 squared. So that's what we're going to do. Right, so that's what completing the square is doing in that case. But then if I have x squared plus ax squared plus bx, take a out as a common factor, which is what we're doing. So we would have had ax squared plus b over a, right? So that's what we just done. And then I'm going to do completing the square on the square bracket here. What's inside the square bracket? So I do a square bracket, open square, x plus b over 2a, because you have to have the new b. The new b is b over a. Close square bracket, square it, take away the square of b over 2a. So that would be b over 2a squared. So that's what, and then close the square bracket. So that's what completing the square is doing. And that's what we've got here. We've got to do this one now. So now I'm going to do completing the square on this. So I got my 2 square bracket x minus 1 over 2, but then you half in 1 over 2, so you get 1 over 4. Close the square bracket, square it, take away the square of 1 over 4, that's 1 over 16. Now close the square bracket, bring down minus 3 is greater than 0. I need to open the square bracket, so I get 2 into bracket x minus 1 over 4 squared minus 1 over 8. because 2 times 1 is 2, so I got 2 over 16, that's 1 over 8. Then minus 3. But that's 3, minus 3 is 3 over 1. And so I would get 2 into bracket x minus a quarter squared minus 1 over 8 minus 24 over 8. And then we get 2 into bracket x minus a quarter squared minus 25 over 8. And so that's the turning point in this case. So we got a good value there. At the turning point, y is minus 25 over 8. That's the y value at the turning point. The x value at the turning point would be x minus 4 equal minus a quarter equal to 0. Therefore, x equals 1/4. So those are the values at the turning point. The x value at the turning point and the y value at the turning point. The x value at the turning point is also the line of symmetry. Now I need to finish solving my equation. Maybe factorization would have been quicker. But this gives us the turning point. Now to solve the equation, I've got 2 into bracket x minus a quarter squared equals, well, let's say greater than, that's greater than 0, greater than 0, greater than 0. It's greater than 25 over 8. So what I did was I moved the minus 25 over 8 to the right hand side, or I add 25 over 8 to both sides. Now I need to divide both sides by 2. X minus a quarter squared equals, greater than 25 over 16. Because if I divide it by 2, I have to divide 25 by 2, which is 2 times 8 is 16. Now I need to square root both sides. So I get x minus a quarter greater than plus or minus root 25 is 5 and root of 16 is 4. Now I need to add a quarter to both sides. So I get x equals a quarter plus or minus 5 over 4. And that will give me the value of x. X equals 6 over 4, which is 3 over 2. And x also equals 1 minus 5 is minus 4 over 4. Minus 4 over 4 is minus 1. So those are my two values. X equals 3 over 2 and x equals minus 1. The turning point, the coordinate for the turning point, if I punch that into calculator, just do 25 divided by 8 minus 3.125. That's the y value at the turning point. And the x value is a quarter, 0.25. To sketch the curve, just draw a line. Just clear this one off. The x-axis will be here. And so I have minus 1, 1, 2, 3. And the y-intercept for the quadratic I'm solving, so this is the quadratic we're solving here, the inequalities, and y is -3. So if I have -1 here, -2, and -3, so we now have the intercept on the y-axis is -3, and because the quadratic is positive, a is positive, is going to be a u shape plus a, and the intercept, the root, is going to be -1 and 1.5. That's 3/2 is 1.5. Okay. The turning point is -3.25, so it's very close to the turning point interception. So at x it equals to 1/4, so 1/4 is here, so that's my turning point here. So the turning point, the y value at the turning point here is -3.125, which is close to the intercept, and the x value is 1/4. So that's 1/4 there. So that's the turning point. So the graph we turn here, cross the 3, and okay. Now the equation of this is y-axis, x equal to 0, and this is the x-axis, and the equation of the x-axis is y equal to 0. That's -x minus y. And so now let's answer the question what we're meant to do. The curve we're looking at is that the function is greater than 0. Right, it's greater than 0 at the point of, from the root, so it's an open circle. You can see an open circle there, and that means this is positive value of y here, and that's a positive value of y. So the domain for that is going to be here, the x values. They're the domains, and the domains here. The range are the y values. So if we write the domain first, so domain, which is the x value, will be, because it's not including the roots, so we do curly bracket, right? And because we're looking at x, so we do x colon. The range is going to be, well, we'd write the smallest first. The smallest is -1, so it's going to be -1. So we say x is less than -1. And we close that, or, union is or. And then we open the curly bracket again. X colon x will be greater than 3/2, then curly bracket to close. So that's how we write the domain. For you to write the range, so let's do the range. Okay, so we are writing from the minimum, and the minimum here is this line here. So if I just say that's the minimum, the y value at the turning point, so that's minimum. And the value of that is -25/8. So when we write the range, we say it's actually equal to the minimum. So we open square bracket, y colon -25/8 is less or equal to y, and is less positive infinity. Positive, so that would be curly bracket, not square bracket, because it's not equal to infinity, because we don't know where infinity is. So that's how you write the y values, the range. So the x values is the domain and the y values the range. And the line of symmetry, which we should have drawn, is going through the quarter and the equation of the line of symmetry is x equals a quarter. You can always find the line of symmetry as well, or the turning point, by using x equals minus b over 2a. As you can see, b is minus 1, so 1 minus minus 1 is 1 over a is 2, and therefore 2 times 2 is 4, so that's 4. So that's a quarter as well. So you can always use that to find your line of symmetry or x at the turning point for quadratic. And then you can substitute x equals a quarter back into the function here to find your y value at the turning point. And that should be equal to what we got here, this y value here.